All right, last lesson here in our with our trig. It's going to kind of put everything together, everything we learned, sine, cosine, tangent, law of sines, everything. Put it all together in real world. Use those skills to solve real world trig problems. This is what you're going to be expected to do on your exam at the end of the year. Putting it all together, all the little pieces together. So just recall a couple little vocabulary. I think we know by now: angle of elevation, angle of depression, just pictures of those for you. Also remember the law of sines. All right, those are just review for you. We're going to get right into these examples. I don't want to keep you too long tonight. You just gonna sometimes, I don't think they'll make you draw these, but just in case, I'm going to have you draw a couple of these to try to get them set up. From a point A at the edge of a river, the measure of the angle of elevation to the top of a tree on opposite bank is 37. So we have this river. All right, we have this river. Okay, river. On the opposite bank, there's a tree. Okay, well, that's a crooked tree. And then the angle of elevation is 37. All right. Now, that's point A. Now, we'll call this T. All right. From a point B that is 50 feet from the edge of the river. So here's the edge of the river, and we're going to go 50 feet from the edge of the river and in line with point A in the bottom of the tree. So that's why I know it looks like that. It says in line with point A in the bottom of the tree. So I know there's point B. The measured angle of elevation to the top of the tree is 22. So there we got another angle of elevation there, and that's going to be 22. So that's what the picture looks like. Now, more than likely, I think they'll give you this picture rather than making you draw it, but we are going to practice drawing them. Find in the nearest foot the width of the river. Now, point B and point A are 50 feet apart, it says. So this is 50 here. We're trying to find X. We're trying to find the width of the river, which is right here. Okay? So if you drew it out well, that's a 7, not a 2. All right. The problem is we want to find this, right? But we don't know another side. You can't find the side of a triangle unless you know another side. So we need to find either the height of the tree first, which we're not going to be able to do, or we could find the hypotenuse of this triangle, the line of sight from A up to T. And that's something we can do. So we're going to call that Y. And we know that if we knew Y, we could find X, because we could do cosine, adjacent hypotenuse. So we're going to do, and I'm going to set this up and leave it, cosine 37 equals X over Y. See that? Adjacent over hypotenuse. So that's great. That we could solve at the end like that. But the problem is you can't find Y until you find X. So we're going to use the law of sines to find Y. We can do that because here's side Y, and I have opposite angle 22, so I can do Y over the sine of 22. Okay, equals, now I got to use this 50. 50 over the sine of, now it's got to be over the sine of the opposite angle. Now here's the opposite angle up here. It's up here. So I can figure that out. I'm going to change colors so you'll know that I entered it after. It wasn't given. The red was not given, but you can figure it out. See this 37-degree angle? That means this angle here, guys, they add up to 180. They're right next to each other. Remember, we learned that earlier in the year. So this is 143. Okay, 143 and 37 is 180. If this is 143 and this is 22, that's 165. So this angle up here must be 15, because the three angles of the triangle add up to 180. So that's just skills from earlier in the year. We're putting it kind of, like I said, everything together we learned. We're putting everything together, not everything, but a lot of different things we learned together. It's just to solve this one problem. So we know that these two add up to 180. We know the three angles of the triangle add up to 180. So I know this is 15. So now I can do 50 over the sine of 15. All right, because that's the opposite angle there. All right, so I'm going to solve this out. Y equals, it'll be 50 times the sine of 22 divided by the sine of 15 after you cross multiply and divide. And that's going to be 67.9527984, I think. All right, that's our y. And again, that's this right here. So now I know that, and I could plug it in right there. So it's cos 37 equals x over 67.9527984. And then, of course, you just cross multiply. And you get, it says nearest foot. So that to the nearest foot, you multiply those across, and it comes out to be 54 feet. 54 feet. All right. Example 2. This is drawn for us. A ship at sea heads directly toward a cliff at the shoreline. The accompanying diagram shows the top of the cliff D, sighted from two locations A and B, separated by distance S. DAC is 30. So this is 30. DBC is 45. It's looking similar to what we just had. And S is 30. So I could fill that in as 30. What is the height of the cliff? I'm going to extend the page just so I can move it up a little bit. All right, so we got to find the height of the cliff. That's H. But again, you're going to need the shared side here. Find the shared side. We'll call that X this time, or you call it Y, whatever you want. Now, same thing. If this is 45, this is 135. All right, and if this is 135 and this is 30, that's 165. So this must be, let's see, this must be 15 up here. This must be 15. All right, so yep, this is 15 up here, the same as last one. All right, so this is 30 over the sine of 15 equals x over the sine of 30. Oops. X over the sine of 30. So that'll be x equals 30 sine 30 over sine 15. And then x is going to equal, it comes out to be 57.95554958. And then we can go over here, since we know x, opposite over hypotenuse, this triangle here. So that's sine 45 equals h over x. So it's sine 45 equals h over x, which is this. I'll just say 57.9, but it's not, you're not really going to round it. You're really going to put the whole decimal in. And then cross multiply. H comes out to be 41 feet. Now, I do want to go back. I'm not going to redo this problem. I'm not going to redo this one, guys. But I think when I did this, I had 16 instead of 15 when I typed in my calculator. So if you were off by like a foot, if you did it and you were off by a foot, I'm probably off by a foot. So just leave it for now at 15 here, because it is 143 and 22, which is 165. So this is 15. It's just on my paper I got 16. So when I calculated it, I'm saying this number and this number might be off by just a little bit because I use 16 degrees. But no big deal. Just leave it for now. You'll get credit. If you did it with 16 and you're off by a little bit, you're right. I'm wrong. All right. I'll see you in class tomorrow.